We have learned about the product rule for finding derivatives. And now let's do one of the practice problems. This is kind of a unique problem. It says that selected values of a differentiable function g and its derivative g prime are given. The complete graph of a function of f is also shown. If we have the function h of x equals f of x times g of x, find the derivative function at x equals 1. This doesn't really look like we would need the product rule because we don't actually have a formal function. We just have this table of values and a graph. But we could still find the derivative, and this is really testing your knowledge of what components are needed to find the derivative when using the product rule. We're going to need to use the product rule to find the derivative of h of x. This is going to be f of x, the first function, times the derivative of the second function, plus the first function times the derivative of the second function. So that is the whole thing written out, but we want to find it at this specific point. So h prime of 1 equals f of 1 times g prime of 1 plus g of 1 times f prime of 1. Now I just have to plug in all these values. Some will come from the graph and some will come from the table. First, f of 1. This is from the graph, and I'm just going to go up here where x equals 1 and find where it intersects. And it intersects at 4. H prime of 1 is going to be 4 times. Now we need g prime of 1. I'm going to go over here to the table. This first column is all the x values. So here is the x value of 1. And we want g prime of 1. So that's going to be 7. Plus g of 1. G of 1 is going to be in the table. We're using the same x value of 1, but now we need g of 1, which would be negative 4. And then lastly, we need f prime of 1. We don't have a graph of f prime of 1, but if we think back to the definition of the derivative is measuring the slope at that point. So I really just need the slope at this point of x equals 1. The slope along this whole section is going to be the same. To do this, I'm going to go back to my algebra days and see if I can use this graph to calculate the slope. I noticed that if I start right here and I go up 1, 2, 3, and over 1, 2, I hit the line exactly. So that's measuring the slope. So I'm rising 3 and running 2. So this will be 3/2. The reason I'm able to do that is because the slope in that whole domain from -1 to 2 is the same. Then all I have to do is a little bit of calculator work. So 28 minus 6. This is going to be 22. One more thing. I'm just going to add a little note here about how we got that 3/2. That was the slope at x equals 1. And that's how you do that problem.